Good day, everyone. Welcome to day 3 of graphing trigonometric functions. Today we're going to be looking at tangent and cotangent. Hopefully you are becoming masters at graphing trigonometric functions so far. And I'm just going to change a few things today, folks, when it comes to tangent and cotangent. Obviously because when we were solving trigonometric equations, instead of using, like 2 pi n, we would use just pi n. Well, there's a reason for that, okay? So it goes back to the period and just, the general looking form of the graph. All right, so here we go. Let's go ahead and jump in and look at tangent today. All these values come from the unit circle. Notice already, though, I'm changing the values. This is now pi over 4, pi over 2, 3 pi over 4, and pi. With sine, cosine, secant, and cosecant, we always ended at 2 pi because that was the period. Okay, tangent repeats itself every 180 degrees or every pi. All right. So if I asked you what's the tangent of 0, you would say 1. What's the tangent of pi over 4? You would say 1 right there. Tangent of pi over 2, you would say undefined. Tangent of 3 pi over 4, you're at -1. And the tangent of pi, you're back at 0. So tangent looks like this. Okay? Kind of has that undefined right in the middle. If you were talking about the periodic behavior, I would say like 0, positive amp, undefined, negative amp, 0. You don't have to remember that periodic behavior, but if that's what's something you want to memorize to help you when you're learning this stuff, that's fine with me. All right, so this is what tangent looks like. The general form still applies. Notice that A, B, C, and D are all still talking about the same thing. All right, A is your amplitude, quote unquote. Tells us how far up we're going to be counting. Notice that the amplitude for this tangent function was 1. So I just counted up 1 and put that dot. That's going to help us draw our tangent. Just like I counted down 1 and drew this line right here. Okay? B is period still. And that is now pi over B. Alright? That is the number one mistake that I see kids make on this. Is that if you use the wrong period formula for tangent and cotangent, you're going to miss the interval length. You're going to miss the stopping point. You're going to miss basically the meat and potatoes of this graph. So you have to really pay attention to the formula that you're using for which trigonometric function. Okay? C again is still your phase shift, folks. And D is your vertical shift. We haven't done phase shift yet. That will come soon. But we have done plenty of vertical shifts. That just moves the graph up and down. So, all right. All the same stuff. Let's just go ahead and jump into some examples and get moving on. Example number 1. Y equals 2 tangent 2x. Amplitude, period. Interval length, and vertical shift. Same 4 questions we need to answer before we can graph. What is the amplitude? 2. That is the number out front. Why did I put quotes around it again? Remember, for ACT, any kind of test purpose out there in the real world, they're only going to ask amplitude on a multiple choice test if it was only sine and cosine. We just use it to help us graph. Period for tangent is pi over b. So we do pi over 2 and we get our period, because this is the number out in front of x, and we got our period right there. Interval length, surprise, is still period over 4. So if I did pi over 2 divided by 4, by the time I flip and multiply, I get pi over 8 is my interval length. There was no vertical shift, so we don't need to worry about it. We're ready to graph. I am still counting by my interval length, folks, and I'm still stopping at the period. So go ahead and get me some tick marks out here. My first interval length is pi over 8. add another pi over 8, you're at 2 pi over 8, 3 pi over 8, and 4 pi over 8. Okay? With tangent, I know that the middle point right here is a undefined, so I can just go ahead and draw my little undefined line right there. Got it? Tangent, will always start at 0 and end at 0, from our periodic behavior. So 0 here, 0 there. Because I had an amplitude of 2, I now count up 2 from my next point and down 2 from the fourth point. And I have my function of tangent that is just a little bit more stretched out than before. Okay? So there's example number 1. Very good. Let's look at example number 2. I bet you can't guess what kind of example I'm going to throw up there. Maybe it'll be negative. Oh, maybe that'll be a vertical shift. I don't know. Let's wait and find out. So let's do negative 3 tangent pi over 3x minus 1. So my amplitude is going to be 3. Don't write the negative, remember? It's just more like a distance. So amplitude is 3. Period is pi over b, which in this case is going to be pi over 3. When you flip and multiply, folks, you get 3. So my period is 3. Interval length is still period over 4, so it's just 3 over 4. And my vertical shift is down 1. Okay? All right, we're ready to graph this thing. So here we go. Give myself some room because everything got shifted down 1. That's kind of like my new x-axis. If I'm counting up by 3/4, this one right here would be 3/4. Add it again, 6/4, 9/4, and 12/4. What do you think 12/4 reduced to? 3. So again, we count by this, stop on that. We're doing a good job. Tangent has a undefined in the middle. All right, so for my new x-axis, or my vertical shift, I'm going to have a 0 on the outside, 0 on the end. Now, because it's negative 3, instead of counting up 3 and drawing my line up, I should count down 3 and draw my line down this way. Okay? From this point, instead of counting down 3 and drawing a line, I should count up 3 and draw my line this way. So notice, you got a positive version up here and a negative version down here. This just opens down, flipping that one negative, it just opens up. Okay? So there are our 2 examples of tangent right there. Let's go ahead and jump into cotangent. Okay? What does the parent function for cotangent look like? Well, here we go. Again, I'm using different values. So this is pi over 4, pi over 2, 3 pi over 4, and pi. Again, if you have your unit circle out and you're looking at it, and I said, what's the cotangent of 0? It's undefined. What's the cotangent of pi over 4? 1. What's the cotangent of pi over 2? 0. 3 pi over 4? Negative 1. And the last one is also undefined. Cotangent of pi is undefined. So this is what a positive cotangent function looks like. Okay? Now, I know I didn't do this with tangent just a second ago, but again, does this graph go on forever? Okay, it does. Now, what do I think about when I see, cotangent or tangent? It could be either one, depending on how you look at it. I think of those little heart monitors, and they're like bloop, bloop. That's actually going the other way, so you'd have a negative cotangent graph, but kind of lets you know you're alive. Okay. So I'm going to write this up here just to talk about it for a moment. A, B, and C, and D are all the same. Notice the amplitude out in front of cotangent was 1, so that tells me that I needed to count up 1 to draw that point, down 1 to draw that point. So your amplitude, again, is going to help us graph these things. B is the period, which is just pi over B. Well, what was the number out in front of x? It was 1, so if I did pi over 1, I get pi. So that was my stopping point. That's where that graph came from. So let's go ahead and look at a few examples of this one. Example number 3. Let's do y equals 3/2 cotangent 1/3 x. We'll have a little bit of fun there with a fraction. Okay. Amplitude, period, interval length, vertical shift. My amplitude for this one is 3/2 or 1.5. We'll use that here in just a minute. Period is pi over b, so it's pi over 1/3, which is 3 pi. Interval length is still period over 4, so I have 3 pi over 4 right there. And my vertical shift, I don't have one. We are ready to go. Still starting by counting by your interval length and stopping at your period. So if I'm counting by 3 pi over 4, this next one is now 6 pi over 4, 9 pi over 4, and 12 pi over 4. 12 pi over 4 does reduce to 3 pi. We did it right. That's good. Cotangent does have undefines on the outside and on the outsides. So on the first one and the last one. Since it's a positive 3/2, I know I'm going to count up 3/2 from this point, which is 1.5. You're always going to be at 0 here in the middle, and down 1.5 to this one. So this is my cotangent graph with an amplitude of 3/2 and a period of 3 pi. All right. Again, I know I didn't write it up here a second ago, but if you wanted to remember like the periodic behavior as like, undefined, positive amp, 0, negative amp, undefined, all I'm doing is just following these points. Like this one was undefined, that's a positive amplitude, that's at 0, and that's a negative amplitude, and this last one is undefined. So however you want to remember it, it doesn't matter to me, but this is what a cotangent graph looks like. Example number 4. Let's go with y equals -2 cotangent 5x plus 2. Let's answer those 4 questions again. Amplitude, period, interval length, vertical shift. So, amplitude is quote-unquote 2. It's going to help us graph it. Please don't write negative just because the negative just tells us it's going to flip. Period is going to be pi over b, so this one is pi over 5. By the time I do my interval length, which is period over 4, and flip and multiply, I'm going to get pi over 20. Good times right there. Pi over 20. My vertical shift, everything got shifted up too. We're ready to graph. Notice I gave myself a new x-axis at positive 2. I'm still starting at my interval length and counting there and stopping at my period. So my first point is going to be pi over 20. My next point is 2 pi over 20, 3 pi over 20, 4 pi over 20, and we're done. 4 pi over 20 does reduce to pi over 5. I know with cotangent, the first one and the last one are asymptotes or undefined. And what about the middle? Well, because this is my new x-axis, I know the middle guy is at 0. Okay. I would count up to if it was positive, like this one up here, but I'm now going to count down to because it's negative. And likewise, I flipped this one, so I'm going to count up to. So this is what a negative cotangent graph looks like. Okay? There is a negative version of cotangent. All right, we are now on to the last part of day 3, which is writing the equation. What does that entail? Well, here we go. Write the equation. Example number 5. What if I gave you a graph that looked like this? All right. Hopefully, just from the shape of it, you should be able to look at it and say, you know what, Mr. Baker, that's tangent all day. All right, tangent all day. Well, good. You should be able to get some partial credit here. This is tangent. Easy. Remember, your vertical shift always cuts the graph in half. If I draw a line that cuts this graph in half, it's actually right on the x-axis. So was there a vertical shift? No. Half the graph is above this, half the graph is below this. So there was no vertical shift, so I don't need to worry about that. However, it does tell me what my amplitude was, quote unquote. How far did I count up or down? Well, the answer right there is 3. The question is, do you make it negative or positive? Well, because you went down first, it is a negative amplitude. Okay? The only thing you're missing is B. Well, just like with sine, cosine, secant, cosecant, you always take your last point of the periodic behavior and plug it in for B. Well, your formula is now pi over B, so when you plug this in and flip and multiply, you're going to get 3 pi over 4. You just wrote the equation of that trigonometric function. All right? One more, example number 6. I bet you can't guess what kind of function we're going to be looking for. That one's going to probably be cotangent, but you know what? We'll see anyways. So let's go with this right here. All right. There's the function I give you. Write the equation. Hopefully you can tell just by looking at it, from the looks of it, this is going to be a cotangent graph because you have undefined on the outside. All right, first one and the last one. Next thing, it's always good, folks, to find that midline. What is this line that cuts it in half? What is that vertical shift, okay, that cuts it in half? So if I drew a line right here, this cuts this cotangent graph in half. I have half above it, I have half below it. That right there is my vertical shift. That's not going to be given to you, so you're going to have to find that out on your homework / quiz and test coming up. So my vertical shift is +2. Half above, half below. Because I know my vertical shift now, I know how far I counted up or down to get to these points. So it looks like my amplitude was 1. Was it negative or positive? Because you counted down first, your amplitude is negative. Okay? The only thing you're missing is B. Like we've done before, you always take your last point, plug it in for b. So pi over 4 pi over 7, flip and multiply, you get 7/4. So your final answer for this cotangent function is right there. All right, so folks, that's a wrap. We are done with day 3, tangent and cotangent. I hope you guys are enjoying yourselves and becoming experts in the world of graphing trigonometric functions. Thank you very much. I hope you enjoyed. Bye-bye.